if you would love to learn more about it, I believe it's in course materials, right? Docker should be in course materials. So I'm surprised you haven't seen it. And I believe test-driven development is in course materials too, right? Okay, we know how people treat course materials. Until exam, nobody looks into them. So, but those things are really important. Why? Because they may very well save your head from falling off. Because kind of you found the stray code in production, you don't understand why it's here, let's do refactoring, you wipe it out, and then kind of your software starts buying stock by hundreds, thousands, generating millions of losses, and nobody understands what's going on. But you have a dire feeling that this is probably because you wiped these 3 lines of code from there. And you are hoping that nobody will find that out. But they will. Unit tests, this is what can save you from that. And Docker, well, most likely you will encounter Docker. Then you will be going to work for somebody, you will see Docker there. So if Professor Callahan would permit that, and if we will have enough time, and if you have an interest for that, we can do like a couple of extra sessions, like how long there we can code together through some unit tests and look into Docker and how it works and how to cook or bake. That's kind of jargon in industry. Join us and see how it works. Like no BS, straight to the matter, doing stuff by hand. But like if time permits and if Professor Callahan permits.
I permit nothing.
That's okay.
Excuse my lateness.
Oh,
Terrible traffic.
No problem at all. Okay, so today we will be talking about Jenkins. Before we will dive straight into the Jenkins, tell me, why do we love make? Everybody is using make utility by now, right? Why do we love it? Go ahead.
We have to type much less.
Right, you are. Because at some moment, you will experience hardcore programming stuff, for example, in operating systems. And to build typical thing in the operating system course, you have to run it through the preprocessor, which will remove all your defines and custom directives and replace them through the code. Then you have to compile it. Then another utility will produce assembler sources from it. And then kind of from assembler sources, you will produce object code. And then object codes will be linked into the executable, which eventually, hopefully, you will run. It's not the end of it. You also need to run a couple of commands to change permissions to make the thing executable. So it's kind of just to build a program and run it, you need to type like 10 commands. And this is if you have only one module. If you have like 10 modules, multiply it by 10. You have to do it by every module, and then in the end, you have to link them. And then you will realize that, somewhere along DevOps, they told us about make. I can write a make file and avoid doing this by hand. And then there you come to appreciate make. But now I see in your faces, but gosh, we don't do C++, we don't even do Java, we do Python. And Python is interpreted language. There is nothing to build there, right? So we don't need make. Hurrah, not entirely. Then you do your Python, and you have to deploy your project. First, you have to compact static files into the folder, collect them. You have to assess code quality. You have to package resolve. Then you have to run unit tests. For that, you have to create environment, which can take a while. Then you run model level test. Then you run controller test. Then you run integration test. Then you have to package test results. Then you have to deliver code base on the staging server. From there you have to apply DB migrations. Then you have to somehow restart the server. Then in restarted you have to run acceptance test. Then you have to package results. And then you are going from staging to production. By the way, you understand the notion of the staging and production, right? Or I can elaborate on it a little bit. Let's elaborate. There are kind of, it's extremely stupid thing to deploy straight to the environment where your users are using your application. Everybody understands that, right? This is because of that we typically have two environments, staging and production. Staging is a kind of stage which resembles production to the closest degree, as close as we can. And we deploy there and we run tests there, and if nothing fails, then we deploy to production. If it fails, that's okay, it's staging, nobody cares about staging, right? We can investigate what's going on and fix it. So you run your automated tests and then you have to deploy to production, and because you are smart, before deploying you do make backup, right? You have to make backup, you have to apply migrations, you have to restart server, you have to run stress tests to figure out if you're deployed everything properly and there is no significant performance slowdown. So kind of 1, 2, 3, 4, 5, 6, 7, 8, like more than 10 steps you have to do. And each and every step takes time. Environment can take like up to 3 minutes for your simple project to build. And all the time you sit around this thing and say, oh, damn. I wish somebody would do it for me. This is the idea of Jenkins. This is why this guy here is kind of like a server in the restaurant. It does all these things for you. So the idea is to automate this pipeline. This thing is typically called pipeline. This is stages, right? And this is pipeline. And if this word resembles something to you, that's right, this is pipeline. This is kind of this thing, moving cars from there to here, and everybody is doing something. On every step, somebody is attaching something to the car to be, and in the end, you're getting your car. This is the pipeline. So this is the idea of the DevOps, to build pipelines, but not like that. It's not like 25 people, each contributing step to something you should do. It's like this. So those guys are doing monkey business for you. You are not studying computer science to do monkey business. Robots do monkey business. But you have to build them, and you have to train them to do monkey business. This is your job, but you do it once, and then kind of you fire and forget. They work for you. Before we dive straight into Jenkins, let's discuss core concepts. Because no matter what you will use SteamCity, or you will use Jenkins, or you will use Azure DevOps, or you will use Travis, concepts are very much the same. Like terminology may differ slightly, but the ideas are always the same. First one, you are always building pipelines. So kind of in the end of every pipeline, there is artifact or set of artifacts. As you can, it may sound like a little bit like archaeology term, but the idea is something tangible. Zip file containing your application, or log file containing a description of how application was deployed in Azure or AWS. This is examples of artifacts. To achieve your goal, you have to perform steps. Step 1, step 2, etc. Every stage of the pipeline contains at least one step. Who does these steps? Agents. They sometimes, like back in the Hudson days, Hudson, it's a kind of future Docker. In the time of the Hudson, they were calling them slaves, but then they kind of removed it because, you know, the controversy it may cause. But still in the books, you will encounter like master and slave concept. So this is agent, basically. And there are masters. Masters, they issue commands to agents who perform steps to produce artifacts. Like, this is that simple. Jenkins is one of the implementations of this automated pipeline ideas. Let me switch my display and show you Docker. Jenkins, sorry. Well, in the core of the Jenkins, there are basically two components. The core, which is Java middleware, and like web interface, which talks to the middleware, and middleware in the turn controls agents. Then you will log into any Jenkins server. You will always see here in the middle, down in the left bottom corner, you will always see build executor status. This is agents. So this is master. It says kind of we have one master running and we have one agent running. And each of them have like two threads which they can use to build something. And then you log in, it will immediately show you like what are they doing, are they free, and if they are doing something, you will see like that they are building, for example, this and this build of this and this particular application. Those things here in the dashboard are projects, and you see them in the different status. So you see kind of all the information, like which build is what, how long, then when was the last success, and like how long it took to build an application, and then you see the weather. It's really kind of simple thing to understand project status. If you will see shiny star right here for online DevOps, what does it mean? Shiny. Everything is fine. Yep. But there is one project which is kind of in the clouds here. What does it mean? Well, it means like there are certain problems there. Rain means kind of multiple builds in the last time failed. And if you will see somewhere here storm, it means kind of it brings each and every time. How do we know like what's happening inside and what is causing? If you will dig into any of these things, you can click. Sorry. You can click this sign, and here you will see the latest builds, what's happening, what's happened to it, and inside the pipeline, you will see test results, which will be showing you like what was broken if it was test, and if you will look into this thing, you will see, sorry, for some reason it's either unresponsive or over-responsive, and I'm kind of jumping up and down. You will see what is causing this statistics you see. So you see like the vast majority of the builds here failed, and you will see like what's happened inside, and you can look into the logs and figure out what exactly caused the problem which broke your build. If you will ever need to configure Jenkins, you will spend quite some time figuring out where the administrative console is. There are two ways to access administrative console, and the latest one, God bless them, they added Manage Jenkins right here in the toolbar, because before that you have to click into this thing, and then it will open the screen there. You can have to click this thing again, and then you will be in the administrative console. But hopefully you will never find Jenkins that old. So every time you need to manage Jenkins, you just go there. Here, like everything what is available to you will be right inside it. So if you want to add a pipeline to your project, what you do? You click New Item, and then there is a number of choices which you can use. Like this, from external job, multi-configuration, project, etc. Those are enterprise stuff. Like most likely you will never touch it, because if you need to have multi-configuration project, then probably special engineer will do it for you, because kind of it's quite a fit. What you will most likely encounter, you will do either freestyle project or a pipeline. Let's look inside the freestyle project, which is this one. And like how it's easy to configure it. You just click configure here, and it will open the administrative console, which basically consists of these 4 major tabs here. As you can understand, Jenkins is kind of supersized or supersized make utility. And this is then it operates pretty much on the same concepts. First, it needs a source code. There it will take the source code. So you have to point it somewhere. There the source code is. Then there are build triggers, like why should I start building? In which cases should I start building? And there are plenty of options here. Like the most popular one is to build on commit. That's typically what you do. You say, for example, then each and every time, then a new commit pop-ups in the master branch, just build it. Build it and run the pipeline. But there are different things. For example, you can do periodical builds, like every night. If your project, at some moment, your project may be really huge. Like it may take, and it's not exaggeration, it may take like 6 or 5 hours to build. And that's a pretty common case. Each and every, if you will trigger this build each and every time then somebody commits, you just can't sustain it. Then you do nightly builds. You say like each and every night accumulate everything which happened during the day and build it. It's one of the possible things. Then you have to provide a build environment. And some applications need a lot of configuration. For example, when you run Jenkins for the Python, you have to create, for example, in the simplest case, you have to create a virtual environment. You have to install all the libraries in the virtual environment. Then probably you have to set environment variables which contain the keys, for example, to access your AWS account. Then you have to set these variables, and then you have to run certain scripts, and then kind of the whole bunch of stuff. And all these things have to be like resemble your development machine. This is when you do like resemblance of your development machine. There's all the environment variables, all the libraries installed, etc. Then there is a build process, kind of exactly like doing something which we need to build here. And then there are post-build actions. Here in my post-build actions, there is a activate Chuck Norris post-build action. If you notice the appearance of the guy briefly right here. So he kind of gives you, by the way, you know the guy, or kind of I'm too old. This is my jokes. Well, kind of Hong Kong had Bruce Lee, and America had Chuck Norris, who is kind of Bruce Lee of America. It was long time ago, so not everybody understands the joke, but like this is what's happening. The guy either showing you that everything is fine, or let's find some broken build. Then it shows, hell, you can see it, but kind of he's going to kick you. And like the message says like Chuck Norris has root access to your system. So be prepared. Okay, so this thing, where did this guy come from? Well, sure, you can write a lot of stuff by yourself, but the most powerful thing about Jenkins, that if you will go into the server management, there is a nice tab here called Manage Plugins. And there is a whole bunch of stuff available here. And I'm scrolling at immense speed, right? So basically, if you need to do something during the build, there is a pipeline for that, believe me. And this is the power of Jenkins.
Do they have a Python section? Can we have a look just so we see what's most relevant to us?
I never looked into it, but let's search.
Yeah. Would be good to see what pertains most to our project.
So there are special pipelines for PyEnv, like in the Py, and there is even some kind of Panda virtual environment wrapper for that. And this one, it basically allows you automate builds in Python, because by default all the builds are written in Groovy. We will talk about it a little bit later.
What do we get? Highland or Flake?
Yes. Sure. And we can even integrate, if you remember the SonarQube analysis, we can even integrate SonarQube analysis right into the Jenkins. So what's going on inside the Jenkins at the moment? Then you will install Jenkins. You will get a directory which is called .jenkins in your var folder, like the default location of all the often modifiable content. In my system, it's var lib Jenkins. In your system, well, if it's Ubuntu, it definitely will be var lib location. If it's something else, it depends. It can be in the var, it can be in USR, it depends like on the configuration. But you will always get a folder named Jenkins. It contains like all the stuff which define Jenkins server. It basically means if you need to move Jenkins server, you take the folder, zip it, move it to the new installation, unzip it there, restart the daemon, voila, your Jenkins is up and running. A lot of teams, they kind of configure their Jenkins in that way. They just, you see that there is kind of a lot of XML files which describe configuration. They configure it right there, and then they move this Jenkins file. They check these Jenkins files into their source code repository, and kind of, if the whole Jenkins server is wiped out, it's not a problem as long as they have access to the source files. But it's not a very good idea, because like in the end, you see that there is a secret key, for example, folder, and there is secret key not so secret. It means like in certain cases, then plugins need backward compatibility. Your security keys may appear here in the open. Having this stuff in the open, like especially if you are in the public repo, it like extremely bad idea, because on the latest AWS reInvent, I was talking to the gentleman from Discovery, and he told me like that once, by mistake, they accidentally put their, I believe it was AWS key, into the into one of the configuration files which were in the open for the public. And but their compliance mechanism detected that and removed the keys 5 seconds later from there. How long it took, how do you think, before these keys popped up in the attempts to hack their AWS instance?
5 minutes.
11 seconds. After 11 seconds, they start registering attempts to use these credentials to gain access over their AWS account. And it was happening for a week, I believe, on growing scale. So these guys, they have like a mechanism to propagate the knowledge they obtained. 11 seconds. So I would advise you strongly not to back up your Jenkins folder, but use other means which we will discuss. But what do we have here? Of course, all the plugins we have. Secrets folder, which will contain all the information pertinent to the environment variables, API keys, etc. And we have a workspace. Workspace, this is actually where everything happening. For example, then you say create a virtual environment, install stuff into this virtual environment. It will, inside the workspace folder, it will create a folder. This is the name of your pipeline. Copy all the stuff there, create environment there, put the variables there. And if it fails, and you need to troubleshoot what's happening. For example, it says file is non-existent. And you say I'm sure the file is there. You go to the workspace folder and you check what's happening there. It's kind of your place to look what's going on here. So you see, for example, you can configure to wipe this folder clean after the deployment, or you can leave the files like the latest version here just for the sake of troubleshooting. So this is what we do for our test project. It's left here just in case you will need to troubleshoot something which is happening. Let's get back to our Jenkins. And let's look into this, for example, very simple pipeline which I shown you. So basically, you see all the pipeline stages here, and you see all the steps like execute shell scripts, invoke top level, Maven targets, etc. Maven, it's a GCC for Java, to oversimplify. There are kind of different actions you can take there. So you can describe your whole pipeline right here from this configuration utility. And you don't know anything about Jenkins. You just go here, click, 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 and everything is fine. Kind of you got your pipeline.
So what's actually running there?
I think it's it's MVC Spring Boot, MVC Spring Boot application.
Right, so we have Git, but does this pipeline actually run anything?
Yes.
So,
it runs Maven.
all right.
It's not our project, it's a different project. I just used it to show how simple it is to configure. So basically you just point it there you want, then you specify what you want to do with the artifacts, and then you click save and it's good to run. There is a problem with this approach here. What you see wrong with this approach? I can click everything here and configure everything here, and I don't need to go anywhere. What's wrong with this approach?
It's not a text file.
Right. Let's assume for some reason your Jenkins server does not exist anymore. Well, things happen. And you need to reconfigure your pipeline. What would you do? You certainly remember that it was around 20 steps, and for sure you remember five of them. And what was other 15 steps? And what have you put inside the pipeline? You have no idea. And that's a problem, this oversimplified workflow. So freestyle workflow, they are just there like for those who are starting this Jenkins. So if you don't know anything about Jenkins and you just, or you have like really small project you're doing for yourself, you just want to automatically deploy it to AWS, then you do freestyle pipeline, and that's okay. Because kind of even if it's wiped out, nobody cares, right? If you do production stuff, then you do this so-called pipeline thing, which implies that this is real pipeline comparatively to this like freestyle thing. Good news for you is that there is a plugin which is called Convert to Pipeline. So you can start this, your freestyle workflow, make sure it works, then click Convert to Pipeline. It will for some time and then produce like the same actions but packaged as a like real pipeline. What is real pipeline? What's inside the real pipeline? Let's look into it. First of all, we still see build triggers, and besides that, we don't see anything. Yes?
Just wanted to point out, if we have it just in a GUI, not only if the server's wiped out, is it hard to recreate. If we break the pipeline itself, we don't know what the previous state of the pipeline was. Someone was clicking, right? What did they just break? What did they click that was wrong? If it's text, it's under version control. We just look back at the previous version and go, oh, they reset this option. We have to put that back.
Yep. So you still have this build triggers thing, and who can read what's going on here? Poll SCM and 5 asterisks. What does it mean? Does anybody do Linux administration? No? Okay. You do.
No, I was going to respond to your first thing. It means do something every minute.
Right. So basically this thing means this is the cron pattern. It means like every minute of every hour of every day, poll SCM, source configuration management, which is defined here. And this is actually what's going on. So you see that the pipeline now is written in some strange language. Maybe somebody recognized the language. No? Anybody doing heavy Java? It's Groovy. So basically all the pipelines, it's basically Groovy scripts. And what we see here, we define a stage in the pipeline, which is called collecting sources. And then we issue command node. It means like allocate agent, any available agent, because we don't specify type of the agent. We just say like node, allocate agent, and then like check out from the master of this particular repository, honor submodules, update submodules recursively, and then kind of next steps when we obtain the latest stages will be create environment. And then we do a whole bunch of Python stuff. And again, please note like very important concept. You have stages and you have nodes. Each and every stage starts by allocating node. You're saying like, give me an agent. And here I'm just asking like any available agent. But I may say, for example, node Windows. Or I may say node CentOS. Why may I need it? Any ideas? Let me help you out. If we will look into plugins, for example, and search for .NET, we see a bunch of stuff popping out. And then we search, for example, for Maven stuff. You see there is a whole bunch of stuff for Maven. And there is a whole bunch of stuff for .NET. So, does it make sense to have installed, for example, .NET Core and the whole toolchain for .NET Core, and the Spring and the Maven, and the whole toolchain for the Spring and Maven on the same machine? Would you do that? Well, Jeff certainly would do that. And then we will spend some time investigating like what's going on, which versions are conflicting. And there are certain components which will outright not work, for example, on Windows and work only on Linux, and vice versa. So you may have to need like the particular versions of Windows, or for example, you run acceptance tests, which is basically a robot emulating real user clicking through the browsers. And you need to test on Safari. Can you do it on Linux? No. Can you do it on Windows? No. You have to allocate macOS agent. How do you create agents? This is really simple. Actually, if you need to make a machine an agent, everything what you need to do you have to download a file which is called agent jar, and it's typically pre-configured, pre-built for your server. So there is a link inside the server which you can download your jar. And then you launch the jar on the target machine, and it provides kind of endpoint which will register this the server, and the node will pop up here and will be available for you to assign tasks. For example, you have an agent type which is agent 1, and now you can do node agent 1 and then run particular tasks assigned specifically to this particular guy. Here you will see like a very interesting thing. You see there is a master, there is an agent, both run Linux. They are in sync, it means like they see each other and can communicate. And they both have 48 gigabytes of disk space available, and they both have 536.75 megabytes of free swap space available, and they have like 48.85 gigabytes freedom space available to them, which makes you to think that they are, what are they?
Same machine.
This is the same machine. I'm just running the agent on the same machine just to show you like how easy it is. If you will look into the definition of an agent, you will see that we basically say, this is Ubuntu type agent, we want to allocate 2 executors on it, and then we access the application on this thing. We just call Java jar bin agent jar, which basically runs an agent on it and makes it endpoint for us to talk to. That's it. We can configure also tool locations on the machine. We can set environment variables, which we were discussing, like that you may need like to store keys or to store configuration variables, etc. So you can do it right from here. So basically it's kind of, you configure remote machine to work for you. This is originally why they're called slaves, because basically master tells the agent what to do. Okay, so how do you feel about Groovy? Do you do Groovy a lot? I don't think so. Nobody does Groovy a lot if you don't do heavy Java. Well, honestly, even if you do heavy Java, Like in most cases, you don't need Groovy. It's just like, if you want, you can use it. If you don't, you don't. So what should we do about that? There is a nice button right here, which is called pipeline syntax. And if you will click it, it will open a nice helper. First of all, there is a declarative pipeline documentation, like how do you describe your pipeline using Groovy. But besides that, there is a declarative directive generator and snippet generator, which means kind of they recognize that you probably don't do Groovy a lot. So they help you out for almost any action which you will need there. There is a snippet available. For example, you need to check out something from the version control. You want to call Chuck Norris to verify the status of the build. Like basically each and every plugin will register his steps with this utility to make it callable for you. For example, if you want to send an email, it asks you like what you want to send, what you want to tell, and then you just click generate pipeline script, and it will generate pipeline script. You just need to copy paste it into your pipeline. But inside the pipeline, you should understand that you should maintain the integrity of the structure. There are stages. Inside the stages, there are node allocations, and there are steps if you would like to have like multi-step stages. So if you need to configure something, don't read documentation, go to the snippet generator, fill the fields, produce the step, take this step and paste it inside your Groovy pipeline. There is only one problem which we haven't yet addressed, is that very often you need to deploy to Heroku, for example, or you need to deploy to AWS, or you need to deploy to Azure, or you have to log into server to issue specific command to make it restart web application. And to do that, very often you have to access the server or like the cloud, this administrative privilege. It means inside your script, you have to put your token or your access ID and access key or your credentials in the open. Never ever do that. 11 seconds. So if you do like something which is valuable to somebody, 11 seconds from there, your credentials will be used to gain access over your AWS instance. How we do about it? What do we do about it? Jenkins has its own KMS, key management storage. It means kind of it's very secure vault which contains your keys, and these keys are always encrypted, and they encrypted like for the very few milliseconds. In your pipeline, they have to be fed into the call like of the remote server, and they are immediately destroyed. They are not stored anywhere, and even if you will, like for the purpose of, for example, debugging, you will ask the server to print them on the screen, it would not. It will just put there like asterisks, wiping out every mention of your credentials. To add credentials, you go to your Jenkins and you go to the configure credentials. And here you can add like whatever key store and whatever you need to to store, I don't know, you may need to store text file containing the keys. You may need to store the credentials. So you add them from here. I'm sorry, my navigation today is like navigating the minefield. I have to target very carefully here. So basically, it's right here in this screen. And then what you do, then you need these credentials. You go into your pipeline. And there is, in the snippet, there is a particular step right here, which is called these credentials. Bind credentials to variables. It's right here. So if you will generate a script, like right here, if you will add the binding, I believe I have something defined here because I'm deploying to PyCharm here. So it's probably either username and password. Yes, username and password. I say USR and pass add credentials. So this is how you add them. And then you generate pipeline script. And it says kind of, for the user NAU staging will be generated USR and pass variable containing USR and pass variables respectively. And then you use them to log in, to issue a command to log into your server. After that, they are destroyed immediately. So kind of you don't have them anywhere in the open. And then kind of all your pipeline at some moment is basically like the Groovy script containing step definitions which you eventually have to put under version control. So basically you do the stuff right here, only then you build the first initial version of the pipeline. Then after that you create Groovy, it's called Jenkins file. So it's kind of, it's a convention. You name it a Jenkins file, you put a Groovy there, and then right here you choose pipeline script from SCM. And you tell which repository and which Jenkins file to use to run this pipeline. After that, you may not log into your Jenkins server at all. So basically, you will just update your Jenkins file, and then pipeline will recognize that update just happened. It will pull the new Jenkins file, consume it, and start running new pipeline. And that's it. So basically, it's kind of very smart thing. Besides that,
So it recognizes the new Jenkins file on check-in to Git?
Yep.
Right, so you don't need to put it on the server.
No, no, everything is automatically. From now on, you are talking to the Jenkins file. Whatever changes you do in the Jenkins file, they immediately incorporate it into the pipeline. So I think that covers like the most of it, but we have to talk a little bit about plugins. And I would say like some of them are really necessary. For example, we have a Jenkins pipeline deploying, running the tests, accessing, I believe, the code quality, and publishing our course to the staging at the moment. Only to the staging, not to the production yet, because we don't have acceptance tests automated yet. Yes, Jeff, I'm looking on you. The question is like 1, 2, 3 at least members of our team who I can recognize from here. Any of you gents is looking into the Jenkins output on daily basis? Okay, I understand. On daily basis, nobody. That's apparent, right? At least once have looked into the Jenkins output. That's the answer, okay? So Jenkins runs, Jenkins publishes reports, etc. Nobody is looking. So you have to integrate a step which will notify everybody about the status. There are multiple plugins to do that. Like the one available out of the box is send a mail. It will send a mail, describe all the steps of the pipeline, saying like, this is what we've done, this is the result, this is links to the log, etc. It's kind of outdated because like nobody's reading email anymore, ha ha ha. Everybody loves Slack, so there is a plugin to publish either the build results to Slack or each and every step as it goes to the Slack. So if it's a teamwork, I suggest you employ this plugin. It's like relatively new, but it does pretty good job in publishing status. Another one, you probably noticed that interface is like pretty much like the time of Chuck Norris, right? There is a new interface which is called Blue Ocean, and it's available as a plugin. And if you look into it, it's kind of very modern, pretty sleek. I love it much more, way more than I love the old one, and kind of it provides a nice ways to see status. It visualizes the whole workflow, and it like shows you all the results in a nice way. So this plugin is called Blue Ocean. Like from the next version of Jenkins, probably it will be default UI, but as of now, you have to install it and enable. And then that's probably it. Like the short summary is that, yes?
I have two questions.
Yep.
So the people who found the secret key within 11 seconds, would they have scripts running, scanning repositories
Yep.
for things that look like a key?
Yep.
Yeah. The second question is, can you actually make a tiny change and push it, and so we can see inside Jenkins when Jenkins is actually doing its work? So you said we could.
Okay.
Yeah. But I think it'd be nice to see the actual stuff running.
Mm-hmm.
We could find something that's not commented, throw in a comment on it or something.
Mm-hmm. I believe there is a README file somewhere. Oops. So it detected the changes.
What does it mean, replay 69?
Basically, it means it's reusing definition.
So just your push to master triggered this process.
I don't see a commit. Probably it was slightly unfair. Probably this thing, it's not a refresh of the status. It's a restart of the build. So I kind of spoiled the fun.
How's that?
It thought that I wanted to trigger rebuild. So it started building before it detected the commit. But after that, we should have another build triggered by the maybe we already have it because we have two agents working.
We have something running, right? So
I just want to see, to show like how it detected the changes. Because then we will see like, you see it says kind of no changes, which is not interesting. I was hoping that kind of, I was expecting that we will wait a minute until the trigger pop up. So we will see like, not it manually triggered, but we will see like that it detected the commits, it added commits to the change log, etc. And I spoiled the fun because like I clicked refresh and it was not a refresh, it's start rebuild. Because recent changes empty. So I manually triggered the build. And because we already built it, it probably would not run it again because kind of no changes.
you could edit the make file.
Let me see the build history.
I have something I want to change in the make file. So
Hell. So what do we change in the make file?
the target validate HTML should go to HTML tests. Because we're trying to make all these names consistent. So we have a real change to make. We might as well just make it. Should be harmless, not any Python code. So at the top, very top level, this is the utils make file. That's not what we want to change. In the top level directory.
No, utils is separate.
Right.
That's not utils. So this one.
No, you're still in utils.
I'm still in
Well,
utils.
close utils. Okay.
I have a whole bunch of stuff here, so it's kind of rich editor, which we were discussing yesterday.
So that's the utils make file. So just close the utils folder. Stop.
It's closed. I'm not in utils folder.
Oh, okay, sorry, sorry. I apologize. So that is the one we want. All right, so the validate HTML on line 23
Okay.
should go to HTML tests as the target.
Just make a change on yourself.
All right. So we just want this go to this. There we go, that's it. So this is just part where, right now, we're working on making our test names of the scripts and the targets consistent across every project. And what this does is it allows someone to move from project to project and right away know what's going on. So the more the naming is consistent, we have the same sort of files, the same sort of targets, the easier it is to switch between projects. And, oh yeah, okay, I just do make HTML tests. It's good to go.
Okay, so. 71 kicked in.
Right.
It says there is one commit making names consistent, so we can go to the GitHub and see exactly what it was. And then kind of, that's a progress going on. And we can see how it progresses through the stages. So you see kind of visualization of the stages defined.
So the creating environment stage takes the bulk of the time.
Yep.
Is that something that can that be optimized? So are there steps? If that starts,
We can reuse environment, but then we violate the idea of kind of keeping a track of if we can rebuild environment each and every time.
yeah, it's not so bad now.
Yep. So you see, like it's went through the stages, everything was fine, and you can look into the logs and see kind of what was happening inside and what was output of the thing. And ideally, in the end, like what we are missing in the end, it should be posting to Slack or sending a message that kind of Jens, the build is completed and there is stuff going in. And
Yeah, we actually, on the EMU project, we've got Jenkins posting the Slack. So that's actually achieved there.
mhm.
But there's a lot of stuff. Cindy, you've got a question?
What would be the reason if Jenkins doesn't log the test for 2 weeks and then it decides to stop? We had that time when it just stopped for 2 weeks and then it came back.
Oh, the server had gone down and a nuke didn't catch it. Yeah, so that's, the server's crashed, but Jenkins isn't gonna run, so.
Or there is a kind of thing which I noticed in our project. When people do implement their features, they sometimes break tests. And for the sake of like, and well, tests start failing, they start reporting that kind of it can't progress to the further stages. And there is a nice directive in the behave and in the all other test runners, which is called skip. And they employ skip directive on the tests which start failing just for the sake of testing. And they forget to remove this directive from there, and kind of tests are reporting that everything is fine because it's a debugging directive. It says just like skip this test, don't run it at all. It reports that tests are fine, and but they are not. They are simply not running, and I noticed it 2 times in our project already.
And by the way, we had this problem where Jenkins had crashed and it's not doing anything on the EMU project. And what we've done since is we put monitoring on it. So now we're actually watching the Jenkins server and we'll get alerts. And so did Cindy and I get the email now, but we should add, now that Jenkins is being used here, you guys should be getting emails from the monitoring too. So you should have.
So far, I didn't get anyone.
Yeah. Well, and actually Adam is setting it up to report to Slack as well. So
Okay.
I've got to run some tests. People, if this is something, if you're watching the Slack channels, you should be aware of. Adam has reports that the monitoring software is going to report into Slack about problems. Well, that's nice that he believes that that's happened. I'm sure he's being sincere. I'm not doubting his sincerity. But has it happened? We don't know unless the server goes down. So in order to see that it's actually working, we need to bring each server down and then get a report, and then we know, okay, now that the monitoring is working, now we can relax a little and know that if it goes down when we don't mean it to, we'll get a report. But it's something, you always have to test your tests. It's great to write a test for something, but you have to make the thing fail, or else you don't know if the test catches failures, right? So you've got to think at the next level, it's not enough merely to say, oh, I wrote a test. Did you test the test? Does the test pass things that should pass and fail things that should fail?
Okay then, so to wrap it up. Automate your integration, automate your delivery. Because first, it will save you time, and the second thing, it's always the same. And it's like, it can be a big problem if like you did a deployment last month and you were dancing around issuing random commands and then deployment succeeded, right? And then kind of next month you do a big release again and you start issuing command and it's not working and you have no idea why. Because last time you thought that was that command which made it happen, but apparently it's not. And you can't figure out what was happening last time, which is not happening this time. So automate your integration and delivery and do it automatically. It means like don't ever change anything in the configuration with all these checkboxes and stuff. Change the file. Change the file, see how it runs. Change the file, see how it runs. Again, do not rely on people because kind of we have makefile which automates everything. And still people are committing like in a different strange way, deploying in a different strange ways, etc. If they don't do it, if the robot does it, and robot does it like in a very particular way which is right, and it's tested and certified by you, it's much more reliable than relying on somebody committing in their code in like 2 hours past midnight and hoping that they will run unit tests and like check what the flake says or pylene says, etc. So don't rely on that, automate it. Don't store anything in the open. If it bears the name key or token in it, it should be in the key vault, key management storage. And then kind of don't forget that you can employ agents on the different machines. You can employ, for example, if you have this large project which is taking like 5 hours to build, you can split it into parts and instantiate like 25 agents building one part of the project, and then finished, put their artifacts into the like common folder, and then the last agent integrates stuff together. And then you are not building for 5 hours, you are building for an hour, which is still long, but it's 5-fold like less than you had before that. And especially if you build for different environments, like you build for .NET, you build for Java, you build for Python, employ different agents for that. It's because kind of sometimes you will run into mysterious errors like you did everything by the book, but it doesn't work. Why? Because somebody installed different version of Maven. And never change anything on the server in the configuration file. Always go to the Jenkins file and work with the Jenkins file. That's all that I prepared for you. And we are straight inside the 1 hour session.